All right, guys, so in the first video, we laid the foundation for what this is gonna look like. In this video, we're gonna refine it a little bit and finally implement this line that you see here. So the actual logic for the app. Before we get to do that, let's clean up a little bit. So I told you how you can run a function sort of concurrently. So if this is your execution context, you can break off and concurrently run a function by using the go keyword, and this is called a go routine. So let's clean this up a little bit. Let's move down here, and let's go extract this into a function. We're gonna call this fetch events. Paste this here. And actually, instead of calling a go routine here, let's make this function return a channel of events, right? So we'll do events. So we'll just assign this here and get rid of this. And this function will have to make the channel. So events, we will make it here. A chan of calendar event. And then we'll return this channel. And this will have to receive the calendar service. This is called service, calendar service. And we'll have to specify that we return the channel of calendar event. Now we can say that we can return a channel from which you can only receive. So you can't push to this channel because this function will be pushing to it. We do that by saying this is a receive only channel. Okay. Now we still have the problem that we had before. Let me just go fix this real quick. Pass in here. So we still have the same problem. This will, first of all, this will block, right? This is a blocking statement. Why? Because whenever you push to a channel, and if the channel doesn't have a buffer, I don't want to go too much into detail here, but it will block until someone can read it. I'm pushing something here, this is gonna block. But even if this channel had a buffer so you could push a lot of stuff into it, even if no one's reading it, it would still never return because we would be stuck in this for loop, right? And it would tick every 5 minutes and put stuff here until the buffer is full, and then it would just block. So we have to run this in a go routine. So let's do that. So now imagine that this has a big buffer, and this loop can just go on and on and on. But it would execute this. It would sort of split this function into a concurrent execution context, and it will return the channel. So then we have a channel that emits events constantly, and we pass it to this function, and this function has to do the wiring. Let's quickly implement these functions with dummy implementations so that we don't have broken code. And we can do func make phone call, and this will receive an event, and it will just print. And we can just do the same for pulse lights. All right. So now we have these 3 dummy functions. Let's do a very dummy implementation of this notify event starting. Let's put it here. Notify event starting. It's gonna receive events, which is a channel of calendar event. It's gonna receive before start, which is a time duration. So this is how long before the event starts we want to trigger the alarm. And it's going to receive a skip already started events, which is going to be a bool. So what we're going to do here is remember that this returns a channel, so we have to make that. Make a chan of calendar event. And then we need to return it. And so that means that we have to specify that here, that we return a channel of events. So if you remember, what this does is it creates a channel and it returns that channel, and it pushes into the channel whatever events come here that are going to start. So let's do a very stupid implementation. Let's range over the events that are received. Is an event. We're going to range over the events, and let's just push to our starting. For now, this function is like really silly, right? It just takes a stream of events that are coming in and it reads them in a loop, and it just puts them in this new channel that we are returning here. And mind you, if I don't execute this on like a Go routine, if I just put this without this function here, this is gonna block, kind of waiting for events to come in, and it's never gonna return this channel. Let's make this read only, okay? So this means we're only going to read from this channel. We're not gonna push anything to it. And now this should work, okay. Oh, and let's make this like a very short value so you can actually see. Let's make this 5 seconds. So you can see how every 5 seconds the events, maybe we can like display the name of the event, right? Let's do that. And this is the event, right? That is gonna happen in a little while. So let's run this. Right, so you see here, every 5 minutes, this is gonna run. So for now, it doesn't do anything, right? But this function just takes events from here and puts them here. And this will we'll iterate on these events being emitted here. And we'll call these 3 functions. In my bonus video, we'll do play submarine sounds. So what we need to do here now is not just blindly pass in any event here, but rather set alarms and then pass the push into this resulting channel. Let's just rename this to event starting. Push here only when the event is actually about to start. So let's do that now. What if we receive an event that is canceled, right? So if the status is canceled, let's just continue, right? There's nothing to do here. We don't care about this. Oops, JavaScript. We don't care about this event, right? Now, what other kind of events don't we care about? Well, we don't care if they've already ended, right? So what if we receive an event here that's already ended? So we don't care about that. So we'll say if event.end.datetime. Oh wait, this is a string. We need to parse this. Hold on. So let's take now. We'll do now is time.now and event end time. This will be time.parse. Want to parse this because this is a string, so it's a string that's been serialized with RFC 59, and this can return an error that we don't care about. All right, so I got these 2 things. So if I say if event end time subtract from now is lesser than 0, so that means the event has already ended, we just continue. We don't care about events that have ended. All right, so if we're here, it's because we care about this event. We care about the event start time, which we'll again have to parse. And we care about the alarm time. So the alarm time should be this time minus the time that we pass in, right? How long before the event starts do we want to fire the alarm? Alarm time will be event start time, add minus, because you can't subtract the duration from a time. So this is the duration, and it's just that you add a negative duration. That's the way that it works. So from now, how long do we have until not the event start time, but the alarm time? Time until alarm time sub now. So we subtract now from this alarm time, and then we know how long do we have until the alarm. This could be a negative number if the event already started. And remember, this is a Boolean that will tell us if we want to skip. If the event's already started and we want to skip already started, then just continue. Okay, so now is the event that we care about. So what can we do? So we're gonna create a go routine. It's gonna be chilling there, just waiting until this time arrives. So we're gonna do timer.new timer until the alarm. Time until alarm. And we're gonna wait for that timer. This is gonna block here until this timer fires. Because this is a channel, right? So remember, if we try to receive from a channel, we block until somebody pushes to it. So we're gonna block here. This go routine is gonna block. And if we're standing here, it's because this timer fired, so it means the event is about to start. So then we do event starting, and then we pass in the event. Oh, and one more thing. Range will actually update this pointer here. Every time we iterate, this E is gonna point to something else. So I actually need to, this is a little technical, it doesn't matter if you don't understand, but I'm gonna call this event, and I'm gonna do E equals event. Yeah, I'll explain this in more detail now. I don't want to spend a lot of time here. But what we're gonna do is, this is a very first approach. Now there's a lot of problems here, but we won't worry about them. Sorry guys, my video cut out, but all I did was I added some print statements on the code so that we can see what's going on, right? Now I was gonna show you how this works now, but I think we need to do one more thing before we try it out, which is, see, this will set an alarm for every event that's coming in. But in reality, because the polling function is just getting events constantly, we will get the same event multiple times. So we need to say, all right, set the alarm the first time and then ignore, right? Ignore any further, I see the same event again, just ignore it. So we're gonna do that, and then and only then we're gonna move to actually running this. Events seen or events alarms, and this is gonna be just a map. So it's gonna be a map of strings to calendar event. And I'm using pointers everywhere. If you come from the JavaScript world, maybe I should be just using values instead of pointers. I'm passing the actual copies around. But for now, I'm just gonna use pointers. We're gonna improve on this a lot in the next video. Right, so then the first thing we're gonna do then is we're gonna check if we've seen this event. We're gonna ignore this and just alarm is set and events alarms, and we're gonna use the event ID. So we're looking in this map, right? And when you do a lookup in a dictionary, it returns the value and whether it found it or not. Okay, so this is a Boolean. It's usually in Go, this is usually named OK. So if this is true, it means that the event is contained in this dictionary. So then I'm gonna do, if an alarm is already set, then just continue. And then here, I'm going to set that alarm. Alarms, alarms, and ID equals the event. All right, so let's try this out now. It's 5:56, and I created an event at 5:58, so in 2 minutes. And I'm just gonna edit the video so you don't have to wait for those 2 minutes. All right, so here you can see when we receive the event, it should fire the alarm in 44 seconds, and then it called all three functions, right? Now we have a lot of improvements to make to this code. First of all, if an event is canceled, we never cancel the alarm, right? So this function here that will block for the timer, it should actually check two things: whether the timer expired or whether the alarm was canceled because the event was canceled. We also never clear this map, right? So once the event ends or the alarm is fired or whatever, we should do a little bit of a cleanup here. There are other things like, what if the event is moved? Then we have to edit this timer so that It changes if the event changes. I'm gonna do all these things in the next video, and then after that, we're gonna have a working implementation, and we can go back here and implement make phone call, implement pulse lights, implement push notifications. But also, like, you'll realize that this is something that cannot run in my computer. If my computer is off because I'm in the kitchen making a sandwich, I'm not gonna get any alarms. So what's the point? So I'm gonna make one video exclusively to explain to you all the things I had to jump through. Yeah, stay tuned for the next video, and we're gonna finish this, and then we're gonna move on to the fun part.